Hello everyone, my name is Rameen Abdal. I'm a PhD student at the Visual Computing Center at KAUST. I'll present our work, StyleFlow, attribute conditioned exploration of StyleGAN generated images using conditional continuous normalizing flows. There are many semantic properties of GANs that lead to various image editing applications. GANs, especially the recently released StyleGAN, has a rich latent space and can be utilized to achieve many image editing tasks. These include image morphing, image super resolution, and semantic editing using the segmentation masks, as you can see in the examples. The challenges. There are several challenges to fine-grained image editing using GANs. The main challenges posed by the GANs are, first, the features are entangled. Like in the first example, if we try to insert eyeglasses on a person, the identity and the lighting also changes, which is undesirable. Second, the latent space is complex and difficult to control. Hence, in the second example, the space is simplified to be linear, which is not always the case. Third, GANs, like any other deep network, lack interpretability, and it is difficult to predict the outcomes. Our solution is to model the latent space of GANs using normalizing flows. Flows are invertible and have properties of exact log likelihood evaluations. We modify StyleGAN architecture by incorporating two properties ensured by our flow setup. Number one, the editing path enabled by our setup need not to be linear. The flow model is used to model the latent space of the GAN, where the transformations can be linear or nonlinear, depending on the latent space. Number two, we also propose a condition-based editing, where the next transformation for editing is conditioned on the current state, rather than assuming the independency. These properties allow us to produce fine-grained edits, and we beat the current state-of-the-art editing frameworks. Here is an overall editing framework of StyleFlow. In the joint reverse encoding, we encode the attributes, in this case, the attributes of the face, and the latent from StyleGAN jointly, to produce a latent in the prior Gaussian distribution. Then we do a forward inference with changed attributes or conditions in the conditional forward editing to produce a new latent that represents a desirable edit. For more information on the algorithm, training, architecture, design choices, and the comparisons of the framework, visit our project page. Now, we show the fine-grained edits produced by our StyleFlow framework with some interactive demos. Now we show some representative edits. For example, here, we do the lighting change. Notice the sharpness of shadows. Here, we do the pose changes. Notice the identity of the face is preserved. Now we do some sequential edits. Here, we change the lighting on the face. We can do gender change. We can change the pose. We can do age transformations, add eyeglasses, edit the hairstyle, grow some facial hair, and voila, change some expressions. Now we show some more edits. Let's edit your favorite billionaire, Elon Musk, and help him grow some beard. Notice the age transformation, the gender transformation, the baldness, and the pose. We can even edit the cars. For example, here we can change the color of the cars. StyleFlow had an impact on the latest research concerning image editing. The paper is accepted in TOG 2021 and will be presented in SIGGRAPH this year. We also got featured on the famous 2-minute papers and gathered media attention. Our repository on GitHub was the top trending repository for multiple days. Finally, our works, StyleFlow and a previous work, Image to StyleGAN, contributed to the recently released neural filters by Adobe Photoshop. Thank you for your time.